In this lesson, we're going to take a special look at solving one-variable equations that have a special consideration, that is absolute value. Now, to begin with, we're going to go through and define what absolute value is, or what it means, to help us know how to solve this when we get to it in our solving process. So, quite simply, the absolute value of a number is that number's distance from zero. Now, distance is purely a number. It cannot be negative. If you're running a race and the distance between you and another runner is 5 feet, we have no way of knowing whether you're 5 feet ahead or 5 feet behind. It is simply the space that's occupied between the two items in question. So when we're going through solving our absolute value equations, we're going to employ a lot of the same methodology we had before, with applying also this definition to that last step. So again, a summarized version of our solving method: simplify each expression of the equation, then use SAD/MEG to solve for the variable, and check your answer. Now, something to keep in mind when we are going through and simplifying the expressions is that you cannot distribute a multiplier over an absolute value the way that you can over a set of parentheses. So if I have, say, 2 times the absolute value of x plus 1, I cannot make this 2x plus 2. That does not work with absolute values. So do not do that portion of it. Combine like terms that are outside of the absolute value group, and simplify any sides that do not have the absolute value themselves. Now, keep in mind also that groups come last when solving, so we're going to isolate the absolute value portion of the equation and then go through and solve what's left and apply this idea of distance from zero. Now, exactly how that's going to look, let's take a look at a couple of examples. So in our first example, we have the absolute value of 2x equals 5/7. So we're going to go through and apply our SAD/MEG method of solving. Do we have any subtraction or addition outside of the group? No, we do not. Division or multiplication? Again, no. No exponents. We just have the group. So applying this idea that it's distance from zero, if I were to take a number line and put 0 in the middle, where could I be 5/7 away from it? Well, that could be a positive 5/7 or a negative. So now that I have my group isolated, I am going to apply that concept. So 2x will equal 5/7, or 2x will equal a negative 5/7. So solving the left-hand equation of this, I'm going to go through and divide both sides by 2, giving me x equals 5/14. On the right-hand side, I'm also going to divide by 2, and that tells me that x is equal to a negative 5/14. Now, I need to check my answers. So, going through and running our check, the absolute value of 2 times 5/14 is supposed to equal 5/7. Multiplying inside of the absolute value, 2 times 5/14 is 10/14. Simplifying that fraction, I get the absolute value of 5/7, and that is supposed to be equal to 5/7. Absolute value of 5/7 is 5/7, and sure enough, that is equal to the 5/7 I was looking for. Sorry, that not 5/5, 5/7. Checking our other one real quick. The absolute value of 2 times a negative 5/14 is supposed to equal 5/7. I'm substituting back into the original equation. Multiplying, the absolute value of a negative 5/7 is supposed to equal 5/7. Absolute value is distance from 0. Negative 5/7 is 5/7 units left of 0, so its distance is 5/7. And that does equal 5/7, so both of these answers work. Now let's do this for the right-hand side. The second equation, absolute value of x plus 1 6/10 is supposed to equal 3 7/10. So, outside of my group, I have no subtraction or addition, no division, multiplication, and no exponents, so I apply the law of the group. This group's law is distance from 0, which tells me that x plus 1 6/10 equals 3 7/10, or x plus 1 6/10 equals a negative 3 7/10. Solving the left-hand equation, I'm going to subtract the 1 6/10 from both sides, giving me x equaling 2 1/10. The right-hand equation, I'm also going to subtract 1 6/10. This one comes out a bit different because x equals, over here on the right, I have a negative 3 7/10 and negative 1 6/10. So when both my numbers are negative, I add them together, giving me a negative 5 3/10. And negative because both numbers were negative. Now, I need to check. So, checking the first one, absolute value of 2 1/10 plus 1 6/10 is supposed to equal 3 7/10. Again, always substituting back into the original equation. Adding those together, I get the absolute value of 3 7/10 is supposed to equal 3 7/10. And absolute value is a positive number, or at least it's not a negative number. So 3 7/10 does equal 3 7/10. That works. Right-hand side, right-hand equation, I should say, absolute value of a negative 5 3/10 plus 1 6/10 is supposed to equal, and those are questionable, supposed to equal 3 7/10. A negative 5 3/10 plus 1 6/10 equals a negative 3 7/10. And we're wondering, does that absolute value equal 3 7/10? Absolute value of a negative 3 7/10 is 3 7/10, and sure enough, that equals 3 7/10. So again, both work. Let's take a look at a couple more involved examples. So 2 times the absolute value of 3 minus 4x plus 5 equals 9. Let's go through and solve this one just as we did the previous. Now, again, remember, we are applying SADMEG to this. So, outside of the group, do I have any subtraction or addition? The answer is yes, I do. So I'm going to subtract 5 from each side of my equal sign, giving me 2 times the absolute value of 3 minus 4x equals 4. Next, do I have any division or multiplication out here? Yes, I do again. I'm going to divide both sides by 2. Telling me that the absolute value of 3 minus 4x is supposed to equal 2. Now, I need to apply the rule of my group. Absolute value means distance from 0. So, 3 minus 4x has to equal 2, or 3 minus 4x has to equal a negative 2. Going through and solving the left-hand equation first, I'm going to subtract 3 from each side, telling me that negative 4x equals a negative 1. Dividing by negative 4 tells me that x equals 1/4. Right-hand equation, again, I'm going to subtract 3 from each side, leave me with a negative 4x equals negative 5. Then, dividing both sides by the negative 4 tells me that x equals 5 divided by 4 is 5/4 or 1 1/4. Either way, it's going to come out positive. I am going to write both options 1 1/4 just so that we have them there available. Now we need to check. I am running a little low on space, so I'm going to do a verbal check. Take my 1/4 and substitute it in here. So 4 times 1/4 is 1. 3 minus 1 is 2. The absolute value of 2 is 2. 2 times 2 is 4. 4 plus 5 is 9, which is what I was looking for. So this one checks out. Next, let's take our 1 1/4. 5/4. That'll be easier to use the improper fraction. 4 times 5/4 is 5. 3 minus 5 is a -2. The absolute value of -2 is +2. 2 times 2 is 4. 4 plus 5 is the 9 we were looking for. Again, both of these work out. Next equation. This one's going to be a lot faster simply by definition of absolute value. We are looking at the absolute value of 2x plus 1/2 equaling a -1/3. We have nothing outside of our group to have to worry about for solving. We just have the group. But the problem comes in with this one item right here. Absolute value cannot equal a negative number. It has to be 0 or greater. So, since we can't equal a negative, there is no solution. Be on the lookout for those. Absolute value equations occasionally are set equal to a negative number. They cannot be that way. Now, that being said, if there are other things going on, multipliers or add-ins, subtracting outside of the absolute value group, that could all equal a negative. For example, if I said the absolute value of 2x plus 1/2 minus 7 equals a -2, this can be solved because first I would have to add 7 to each side, in which case my absolute value of 2x plus 1/2 would have to equal 5. My absolute value now equals a positive number. This could be solved. We're just not going to go through that process. So when your absolute value is isolated, it cannot equal a negative number. Just move on after you write no solution. Now let's take a look at some more interesting cases. Writing equations. The minimum size of an official ball for the NBA is 24 1/10 centimeters. The maximum size is 25 centimeters. We need to write an absolute value equation to represent these sizes. As we were looking at those absolute value equations already, there's a specific pattern that kind of goes through the system. In fact, the way it works is absolute value of our variable minus what we're going to consider the middle has to equal what is called the tolerance. Tolerance is the name of the distance from the middle to either end. I'm just going to say to the ends. That way it can be the right end or the left end. So how far can we move from that center ideal? Here's my number line. Here's my middle accepted value. I have a max and a min. That distance from minimum to middle or from middle to maximum is the tolerance. So what we need to do is find those two values in order to write this equation. So first, how do we find the middle? We take our 25, subtract our 24 and 1/10, and divide it by, add them and divide by 2. So when we add these together, we get 49 and 1/10 divided by 2 gives us 24 and 55 hundredths. So that is our middle. Now, our tolerance, our distance from that middle to either end, we'll simply take either end and subtract that middle. So 25 minus 24 and 55 hundredths. Going through using our borrowing and subtracting properties, we're going to come out with 0 and 45 hundredths. So if I add 45 hundredths to 24 and 55 hundredths, I get 25. If I subtract it, I'll get the 24 and 1/10. Now, writing our equation, because we're talking about the size of the basketball, I can really use anything, or let's say it is the diameter. This is diameter. So the diameter of the ball minus my middle, 24 and 55 hundredths, has to equal that tolerance, 0 and 45 hundredths. This is our absolute value equation to represent the minimum and maximum sizes. Anything in between, of course, is acceptable. These are just those two end values. Now, some other cases. What happens when we have absolute value on both sides of our equal sign? Same thing. We're going to apply the same principle we had before. So, all the absolute value is isolated, which in these cases it will be. So 3x minus 4 equals x, or 3x minus 4 equals a negative x. Solving the left-hand equation, I'm going to subtract 3x from both sides. That way I've gathered all my variables to one side. Tell me negative 4 equals a negative 2x. Then divide by negative 2. Tells me that 2 equals x. Next, our right-hand equation, I'm going to subtract 3x again from each side. But this time, negative 4 equals a negative 4x. Now, in order to isolate that x, I'm going to undo that multiplication with its inverse operation of division. Divided both sides by negative 4 tells me that x is equal to 1. Now, let's go through and check these. Left-hand side, absolute value of 3 times 2 minus 4 is supposed to equal the absolute value of 2. I'm substituting that x value into both places where the x is shown. So simplifying the left, the absolute value of 6 minus 4 is supposed to equal 2. The absolute value of 2 is supposed to equal 2. And again, these are supposed to equal, so we're questioning that. And yes, 2 equals 2. Okay. Right-hand equation, or right-hand solution, the absolute value of 3 times 1 minus 4 is supposed to equal the absolute value of 1. So the absolute value of 3 minus 4, because 3 times 1 is 3, is supposed to equal 1. 3 minus 4 is negative 1, so we have the absolute value of negative 1 is supposed to equal the absolute value of 1, and we get 1 equals 1. This one checks out also. So we have multiple solutions even when we have absolute value on both sides. Now, our last case we're going to look at today, the absolute value of 2x plus 12 equals 4x. Both sides are simplified as far as they can go. Now we apply our SADMAG solving. We have no subtraction, addition, multiplication, division, or exponents outside of our group. So we're going to apply the law of the group. That law tells us that 2x plus 12 equals 4x, or 2x plus 12 equals a negative 4x. Solving the left-hand side, we're going to subtract 2x from each side of our equal sign, giving us 12 equals 2x. Next, do we have any division or multiplication? Yes, we're going to divide by 2, since we had that 2 multiplier on our x, and we come out with 6 equals x. Solving the right-hand equation, again, subtracting 2x from each side, leaves us with 12 equaling a negative 6x. Then dividing both sides by negative 6, we come out with x equaling a negative 2. Now, go through the work of checking these. So, back into the original equation, the absolute value of 2 times 6 plus 12 has to equal 4 times 6. Absolute value of 12 plus 12 is supposed to equal 24. 12 plus 12 is 24, so we have the absolute value of 24 is supposed to equal 24. And yes, 24 does equal 24. This one checks out. Next one. Again, substituting back into the original equation, absolute value of 2 times negative 2 plus 12 is supposed to equal 4 times negative 2. So, absolute value of a negative 4 plus 12 is supposed to equal a negative 8. The absolute value of 8 is supposed to equal negative 8. And again, all these are supposed to equals. So, absolute value of 8 is 8. That's supposed to equal a negative 8. No, it does not. This one does not work. So what happened here? Occasionally, when you're solving equations, especially special consideration equations like absolute values, and you do have an x on both sides of the equal sign, and that can happen in the other situation also, all of your math is correct, but because of the case of your group, you come out with an answer that does not work. This is called an extraneous answer. And as the word would suggest, an extraneous answer is extra. It's something that mathematically works out in the solving process, but does not work out in the checking process. This is why it is so important to always check your work, whether it be a written check or a verbal check as you go through. The work was done correctly, but not both of these are solutions in this case. So we have to take a look at those. Okay, so absolute value, same solving technique, just different thing when it comes to breaking apart our group. Make sure you have this, good notes, ready to work, and be ready to use it moving forward, because this is just solving simple equations. We're going to get to the point eventually where we have multiple variables, and all these things will have to be looked up again. So, be ready to use it. Let's have fun.